In our previous video, we introduced LiGuard and its graphical user interface and implemented a very basic pipeline of reading and visualizing point cloud data. In this video, we will be diving into a slightly complex pipeline to introduce various capabilities of the LiGuard. The pipeline is titled Automatically Generate Detections in Roadside Point Cloud Data. And as the name suggests, what it does is that it takes as an input the point cloud data coming from a roadside LiDAR sensor, and it generates detections on it. The detection labels can be pedestrians or cars. The pipeline goes like this. First, we gather some point cloud data in the form of individual point cloud frames. We calculate a voxel density based filter and uses some threshold to remove the background points. And then for every frame, what we do is that we crop the point cloud to the region of interest, and using the filter that we calculated, we remove the background points. The remaining foreground points are clustered together. We fit axis aligned bounding boxes on every cluster and use the shape heuristics of the bounding box to give the classification labels. We then store the labels in the OpenPCDet standard format. OpenPCDet is a library for training deep neural networks for point cloud data. We visualize the results that are like the bounding boxes on top of the point cloud, and the pipeline continues on to the next frame and performs the same operations. Let's go ahead and implement this pipeline in the LiGuard. To do that, first fire up the LiGuard by typing python main.py and hitting enter. The introduction and installation of this is in our previous video, so if you haven't looked at, please go there and check out. Click on the new button to create the configuration, and the first thing that you will see here is setting the data sources. So for this example, the dataset, a roadside LiDAR dataset, is available on our Google Drive, and a link to it is available in the examples folder, data subdirectory, pipeline 1 and 3 subdirectory, and in there is a readme.txt. I will also provide this link under this video for convenience purposes. You can go ahead and download this dataset, or you can use your own custom roadside LiDAR dataset. However, for the demonstration and example purpose, I would recommend you to use the same dataset. So once you will download it, you will see that it has only one folder which contains the point cloud data, and there are 1,000 frames in it. The reason why we are using 1,000 frames is because the background filter that we need in this actually need multiple frames. The technical details of how a spatio-temporal density filter works is beyond the scope of this video. However, for just basic introduction, it is a filter that uses multiple frames to see the locations where the point density was high, and then consider those locations as the backgrounds. And if any point in the future fall in that location, it also considered it as a background. So this is a background filter that uses density based filtering. Going back to our configuration window, the first thing is passing the data path. So I have my dataset downloaded here, so I will just copy paste the root path here. The LiDAR subdirectory is called Velodyne, as you can see here. So the camera and label and Caleb, since they are not available, you can keep them there and just disable. Just make sure that the reading for camera, Caleb, and label is disabled here, as is the case here, and only the LiDAR data reading is enabled. Also make sure that the data type is right. So this dataset is in bin format. Some datasets are in NPy formats or other formats. So LiGuard supports a lot of different data formats. So you just type the file type and probably it will have the implementation for that. If there isn't, please create an issue on our GitHub repository and we will try to fix that. Alright, so once you have that, you can just click apply to kind of see if the data loading works. Hit the space bar to play this. Actually, I just loaded 10 frames, so I will use the 1000 frames here and hit the space key again to kind of see, okay, all the frames are working. So this is good. Next thing that we have to do is to actually implement the pipeline. So the stages in this pipeline are all actually standard part of the algorithmic library of the LiGuard. So all these algorithms that are being used here, such as the spatiotemporal density filter, is already a part of the algorithmic library of the LiGuard. Cropping, clustering, fitting axes, align bounding boxes, all of these stages are already implemented there. So we just have to enable them. And since they are already, part of our standard library, you will actually see them in your process, LiDAR, configuration. So if you go under this proc category here and see under the LiDAR, so these are all the algorithms that you can apply that comes built in. Okay, so there are a wide range of algorithms with more being added frequently. So if you see that for this we need first of all a background filter. So BG filter STDF is a spatiotemporal density filter that is already part of the LiGuard algorithmic library. So we'll just enable it. You can see, look at it, different parameter. I can quickly go through them. So the number of gathers is 6. And in each gather, there will be 10 frames that will be gathered and stored, and then 100 will be skipped. So it will capture 10, gather 10 frames, skip 100, gather 10, skip 100, and it will do that for the 6 iterations. The reason behind that is that for any background filtering process that is analytical, you don't want to gather very sequential closed frames, because sometimes stopped vehicles or pedestrians, they can get identified as the background, so you don't want that. So just skip frames after every few frames. So this will give you an actual background point cloud better. The rest of these are the background filter's own variables. So this is the number of points that it expects in each point cloud. And if the number of points are more, it just crops them. If they are less, it zero pads them. The LiDAR range is the voxelization actually area in which the voxelization will happen. This is each voxel size, and this is the threshold for the calculation. So for, let's say, if a voxel has more density than 0.5, it is considered background in this case. So what we will do is we will enable it and hit apply, and going back here, so we will just press the space key and it will start this process. This algorithm is now part of the pipeline, and if you see in the logs, it's actually running on and gathering frames. So we will wait until it generates the filter. If you see now, you actually have this filter generated, and you see a lot of background is getting removed. So this is a standard background filter. You can tune different parameters of it to see if it's better. So for example, you can set a density threshold to lower to see if you can get any better results. And this is the beauty of the LiGuard, that you can actually dynamically change the parameters of your algorithms to kind of quickly see how they perform. So this helps you make an efficient pipeline and a more fine-tuned pipeline by interactively changing the parameters of its different stages. So since now we have the background filtered, we can go ahead and go to our next stage. So actually we are here. So we calculated the background, we applied the cropping. So actually, did I apply the cropping? No. So let's do the cropping as well. So just click enable and hit apply. So now you have cropped point cloud. Okay, so this gives you a nice region of interest to focus upon. Once you have that, if you go here, so we actually cropped it to the region of interest. We already calculated the background filter. Now we have cropped the background, and we are also applying the background filter. So we are removing the background points. The next stage is clustering, which is also, there is a standard cluster available in the LiGuard, which is called TEPP DB scan, and this is an implementation of actually an algorithm that is available on the GitHub, and there is a paper as well. If you want to read more details on this, you can go ahead under our algo in the LiDAR, and this cluster TEPP DB scan. So this is the paper, and they have their GitHub repository available in their paper. So you just go ahead there and see what the implementation of it. We are just using that package directly here to kind of cluster. Okay, so when you click check, apply again, and you will see that although it has clustered, and the clustering is not working very well because all the points are given one color, which means that it is a single cluster. We can change the parameters live, so I will just change it to 1. Or maybe 1, just 1.0 and 4 here to kind of see. Okay, I applied it, and you can see that the clusters are getting better, but they're not still correct. So to even more fine tune that, let's go ahead and do it like 1.4. Still not very good, so let's do maybe 1.8. So these are the different parameters of the algorithm which are out of scope of this study. However, like quickly saying that DB scan algorithms usually have two parameters, a scanning radius and the minimum number of samples to be considered the part of the part of a cluster. So I just set these variables, and you can see now the clustering is working actually better because the vehicle is given single color, whereas the other objects in the scene are given a different color. Okay, so for example, if we go to some other frame where there is a vehicle, so you see like this vehicle is red and this one is yellow. Every frame they're switching colors because there is no tracking going on. However, the clustering is working. Once we have the clustering working, the next stage in the pipeline is to fit an axis aligned bounding box. For that, LiGuard provides an algorithm called cluster to object, and what it does is that when you enable it, it kind of uses like each cluster's minimum and maximum bounds to draw an axis aligned bounding box around it. You can also use the oriented checkbox here, which kind of draws the minimal bounding box around that cluster, so it will be a rotated bounding box. However, for this purpose, for this use case, we are just using the axis aligned bounding boxes, so we'll keep it unchecked, and based on the box that will be calculated and its base length and height parameters, it will be given a classification label. Okay, so this is entirely an analytical pipeline where there is no deep learning based detection. We will cover the deep learning based detections probably in our next videos, but for this video, this analytical pipeline is being studied. So once you have that, you can go ahead and you click enable and apply it. Okay, so now you see that there is a bounding box around this vehicle, and if we just play, you can see that this other vehicle also has a bounding box. So these are the labels that are getting generated, and you can just hit space bar and you will see that this pipeline is now working on sequentially, processing all the data. However, this data is just being visualized, it is not stored. So we will go ahead and implement this stage here, which stores the labels. Again, LiGuard provides the the functions for storing the labels. So we will just enable as a post process. So in the post process, we enable create PC.dataset, dataset, and what it does is that it takes in the labels from here and store them in the PC.dat standard format. PC.dat is a library for training deep neural networks for point cloud data. So we'll go ahead and we have enabled it here, and now we can just go ahead and apply. Okay, and press the space key to start generating the data. So if you go here in the log, it shows different warnings as well, that some bounding boxes are not generated. However, we see no errors, which means the pipeline is working. We can pause this pipeline now and see if the output was actually generated. So this what LiGuard does is that this storing function for the labels, it creates a folder named output, and inside it creates the folder for the process category that it was in. So it was a post process, and it was a creation of PC.dat dataset. So if you open it, now it has the labels in it. Okay, and these labels are in PC.dat standard format, which is XYZ center, XYZ DXDYDZ, which is like the extent of the bounding box, the orientation of the bounding box. Since these are axis aligned bounding boxes, so they have a 0 orientation, and the classification category. So it generates the data set. So yeah, this creates one pipeline. However, LiGuard allows you to create custom functions and add them into your pipeline. You can go to our documentation website here, and under the algo you will find the details on how to implement your own custom algorithm. In the future videos, we will also be showing that in a more hands-on fashion. So we'll be showing how you can add new algorithm and test it. But for this video, the pipeline implementation is complete. So thank you